In Ohio, tragedy strikes one of America's busiest highways.
I could see a big slab of concrete, but it still really had no idea what exactly happened.
In California, a catastrophic dam collapse causes a tsunami of destruction.
If you had been standing here when the dam failed, you would have been washed away.
In Italy, a vital bridge comes crashing down.
The entire bridge toppled like a line of dominoes.
And in Massachusetts, the world's tallest academic library starts cracking at the seams.
When you have something of that scope and something like this happens, people are going to say, what are we going to do about this?
With big builds, even the smallest mistake can be a huge disaster. From miscalculations to misunderstandings, some with deadly consequences. These catastrophes are every engineer's worst nightmare. In every step of big engineering, from design to construction, the devil is in the detail. The same is true when it's time to bring things down. Like this catastrophe in Ohio, as highway disaster strikes in the middle of the night.
While the bridge actually did fall, it's sitting on the highway. It's not something, even in a lifetime, you might expect to see.
A routine demolition that went tragically wrong.
Deconstruction is possibly the most delicate phase. You need to be careful because you may take the whole thing down.
And caused chaos on one of the nation's busiest highways.
It was a catastrophic pancake collapse. This had an effect on a lot of people for a very long time.
Cincinnati, Ohio is a melting pot. A mix of East Coast, Midwest, and the South. But the crossroads isn't just cultural.
Some of America's most important trucking routes pass through Cincinnati. With around $400 billion of freight crossing the river here every year, a lot of it on one of the nation's busiest highways, Interstate 75.
Bill Reinhardt is a local reporter.
I-75 stretches from Michigan all the way down to Florida, from Detroit to the Gulf of Mexico. It passes through Cincinnati, it passes through Atlanta. 3% of the annual gross domestic product of this country traveling north on 4 lanes and southbound on 4 lanes. That's not a lot of space for a lot of gross domestic product.
In 2010, work began on an infrastructure project to widen and modernize a nearly 30-kilometer stretch of the I-75, including vital overpasses like this one, the Hopple Street Interchange. A local police officer for nearly 20 years, Don Whirling, explains.
The Hopple Street I-75 connection right here is the main artery that takes you up to the University of Cincinnati, all of our major hospitals. So it kind of connects east and west, and it connects a lot of people coming from the suburbs, coming from Kentucky, coming from downtown. So the Hopple Street overpass is very, very important.
But this isn't the first overpass at this location. It was built to replace this shorter, narrower bridge constructed in 1961.
The overpass needed to be widened. At the same time, the interstate also needed to be widened to accommodate growing flows of traffic. So what they did was got rid of the old overpass and built a new one, and then simplified the on and off ramp.
The old bridge might look very basic, but the structure relied on a careful balance of forces.
The old Hopple Street Bridge was built in 3 sections. A 12-meter west span and a 14-meter east span, each projecting nearly 3 meters over the roadway. Balanced or cantilevered over the columns, the 2 ledges supported the longer center span, creating a 28-meter wide gap for traffic. With balance being key to the bridge's structural integrity, demolition was far from simple. Associate Professor of Engineering, G.A. Rosati, explains.
The deconstruction phase or the demolition phase is probably the most dangerous phase in the life of a structure because you're taking away parts that contribute to the stability of the structure. When you come to the bridge, you start removing the deck. You need to be careful with that.
Monday, January the 19th, 2015. The demolition crew was on the second night of the job.
The idea was to remove the concrete from the east span, then continue all the way across before removing the steel structure. That way, the road below could be kept open for as long as possible.
An excavator with mechanical jaws had chewed the concrete from the east span and was working its way towards the middle of the bridge.
Around 10:30 p.m., disaster struck. Captured on grainy CCTV, the entire center span suddenly collapsed.
The Hopple Street Bridge just collapsed over 75. We'll need heavy rescue, and we're also going to need to shut down 75 South.
Police officer Don Whirling was working the night shift when the call came through.
My boss calls us and he tells us that we need to gear up, that the bridge fell. So we got our gear together and we headed out there.
What should have been a routine demolition was now a major disaster.
We need to stop the traffic. Don't let the traffic come off that ramp. How many injured people do you have down there?
Tons of concrete fell around 6 meters. An excavator, its operator and foreman all went down with the bridge.
I don't think your mind can actually grasp it until you see it. It's not something, even in a lifetime, you might expect to see.
As word spread about the catastrophic collapse, reporters like Bill Reinhardt rushed to the scene.
I could see a big slab of concrete with an excavator on top of it, but it still really had no idea what exactly happened.
It was a close call for traffic, with one truck driver crashing into the debris.
One semi slammed into it. That driver had some minor injuries. He was treated and released. That was it.
Not everyone was so lucky, although the excavator operator survived the fall. Tragically, the foreman died in the devastation. But with the road open at the time, the injuries and death toll could have been much higher.
On the camera, we can see cars actually going under the bridge. By some miracle, there's a break in traffic, the bridge collapses. There could have been a dozen cars underneath of it when it came down.
While the city was in shock, one of the busiest highways in the country was at a standstill.
I-75 southbound is a major artery, and to cut it off at any point interrupts a lot of traffic and a lot of commerce. Traffic was kind of a mess. People had to find other ways to get where they were going.
Residents and travelers alike wanted to know, how could a routine demolition go so disastrously wrong? From the wreckage, investigators quickly established that the type of bridge played a central role.
So with a cantilever bridge, balance is everything. Not just during construction and operation, but demolition too. And taking it down from one end had caused serious problems.
Associate Professor of Engineering, G.A. Rosati explains.
During deconstruction or demolition, you need to make sure that the rest of the structure remains stable. So by starting to remove the loads at one end, the bridge became lighter at that end. That end of the bridge started lifting up.
As the excavator was removing the concrete chunk by chunk from the east span, it was leaving the girders exposed. But without heavy concrete to hold the steel beams down, they began rising from the pier.
The previous night, the team noticed the girders lifting up off their bearings. The demolition was immediately shut down until a solution could be found.
They tried a fix by basically using rods and anchored bolts to basically affix the ends of the girders of the bridge back to the abutment so that it would not continue lifting.
But the bridge was so far off balance, the fix wasn't strong enough. With most of the concrete now gone, the girders on the eastern span tilted up, breaking the bolts that held the end of the center section. As the girders fell, the bolts on the west end failed too, and the whole span dropped to the road.
Ultimately, the bridge lifted on one end, twisted, and that was sufficient to drop the support of the middle span. It slid, lost the support on the opposite end, and basically fell down onto the highway.
It's a bit like being on a seesaw. If one person jumps off, their end flies up, and the other person will crash to the ground.
With hindsight being what it is, they should have started removing all the weight from the middle, and then started working from both ends to maintain symmetry of the forces as much as possible. The biggest issue that caused ultimately the failure was starting from just one end that caused that seesaw effect.
With the main artery blocked, getting I-75 south reopened was a major priority.
With more than 150,000 vehicles needing to use this road every day, teams worked tirelessly to get this vital route up and running again.
Just 2 days after the disaster, on January the 21st, 2015, the debris from the old overpass was cleared and I-75 reopened. Hopefully, when it comes to demolition, nothing like this will ever happen again.
The tragedy of the Hoppel Street collapse is an opportunity for learning. And unfortunately, one of the best ways of learning is to learn from mistakes.
There's a reason they do a lot of the heavy work at night. It's because the traffic is lessened. For this to happen when it did, I don't want to say fortunate, but it could have been a lot worse.
When building big, engineers need to work hand in hand with Mother Nature. Underestimating her power can result in devastating consequences. Like this disaster in California, a catastrophic collapse of epic proportions.
The dam actually failed. It released about 12 billion gallons of water, a gigantic wave down that canyon.
An unstoppable tidal wave of devastation and destruction.
A 100-foot wall of water coming down faster than anybody can run, destroying everything in its path.
And a tragedy that shook the entire nation to its core.
This was the deadliest civil engineering failure in the United States.
Los Angeles, the city of angels, now America's second largest metropolis. The home of Hollywood wasn't always a West Coast powerhouse.
LA originally had a population of just 300 or so, but boomed when oil was discovered in the 19th century, attracting people from all over the country.
As the city grew, so did its need for water, but in this arid landscape, that was in short supply. Archaeologist and Angeles National Forest manager Dave Peebles explains.
The limiting factor was always water. In this area, you could have a drought that, a drought for a year is nothing. So they really had to come up with a strategy to support that type of population density.
To quench the city's thirst, in 1913 they opened this, the LA Aqueduct. A plan as bold and ambitious as the man behind it.
LA's Mulholland Drive is world famous. It's named after William Mulholland, a self-taught engineer who became a Los Angeles legend for bringing water to this thirsty, dry city.
William Mulholland came up with the idea to transport water from Owens Valley. And that's about a 233-mile stretch of aqueduct that they constructed. Monumental construction.
Diverting water from high up in the Sierra Nevada mountains, this was a highly efficient and truly remarkable piece of engineering.
Back then, this gravity-powered engineering marvel delivered more than 80% of LA's water. And today, more than a century later, it still provides water to millions of folks from Los Angeles.
But by the 1920s, the aqueduct alone couldn't keep the city hydrated. So Mulholland came up with another bold plan. to build 7 dams, creating huge storage reservoirs, the largest of which, around 60 kilometers northwest of LA, would be the St. Francis.
Right now we're standing on the site of the St. Francis Dam. If you would have been standing here, 100 years ago, you would have saw a gravity arch dam, about 200 feet across the span, and then it would tie into this east-west ridge, concrete that ran along for about 500 feet along that way.
Standing around 62 meters tall, the St. Francis Dam was known as a curved concrete gravity dam that relies on its weight and internal strength for stability. As Water Department Director Stephen Cole explains, it was designed very much like this sister dam.
We're at the Mulholland Dam, built in 1924, exactly the same as the St. Francis Dam. It's a concrete gravity arch dam. The gravity is how much weight the dam has, and the arch is the actual layout of the dam. And that arch actually helps resist the forces of the water as it pushes against it.
The St. Francis Dam was made of giant concrete arches, stacked on the ground like steps. It looked like a vast curving staircase that sealed the canyon, creating the huge reservoir.
Opening in May 1926, the St. Francis Dam held around 54 billion liters of water, enough to supply the city for a whole year.
The dam was the end-of-the-line storage of that overflow that you weren't using, so you could bank and store for those dry times that would eventually come.
But what happened next had Angelenos wishing for drier times. Early morning of March the 12th, 1928, the dam keeper called designer William Mulholland urgently.
The dam keeper had reported leaks, muddy water, which is a real danger sign for dams. Mulholland came out and made a decision that that was nothing out of the ordinary.
The rest of the dam was inspected and given the seal of approval. But just 12 hours later, at 2 minutes to midnight, disaster struck.
That's when the dam burst.
Around 54 billion liters of water flooded the valley below. A more than 40-meter high wall of water came crashing down.
Faster than anybody can run, destroying everything in its path.
As it picked up speed, it took out the dam's powerhouse, along with most of the workers inside.
It completely took it off its foundation. I mean, that pretty much cut off any of the communications that would have been able to happen.
Without power or the ability to communicate, no one downstream of the dam knew that a massive torrent was heading their way.
The force of that water was tremendous. The wave went all the way to the ocean.
The death toll was enormous, and while exact numbers remain unknown, the latest figures suggest that sadly more than 450 people lost their lives.
The death toll, we're still assessing it. The dam keeper, he's the one that initially reported the leaks to Mulholland. His son and his wife were all killed.
As Professor J. David Rogers explains, the scale of the tragedy was unprecedented.
This was the deadliest civil engineering failure in the United States during the 20th century.
With the devastation nearly total, there were few clues left behind. But investigators determined one major cause was a last-minute design change to give the dam greater water capacity.
They extended the height of the dam during construction twice by 10 feet without doing any other kind of engineering tests or analysis.
That seemingly small increase had major consequences. Stephen Cole from the LA Department of Water and Power explains.
When you raise the height of the dam, you also increase the pressure, pushing on the dam both horizontally and also what's called uplift, which is water that percolates through the ground, through the rock foundation, and is actually trying to lift the dam up. So the higher the water surface, the more pressure you have pushing the dam up, and the more pressure you have pushing the face of the dam too.
He didn't add width to the base, so he had a more dangerous dam than he realized and then uplift force creates instability.
The increased height wasn't the only issue. There was a problem with the construction of the dam itself.
When concrete sets, it expands or contracts with temperature changes. So normally, flexible joints are built in to minimize cracking. But here, that wasn't done.
The dam developed 4 huge cracks, but because the reservoir was full of water at the time, these could only be sealed on the outside wall or downstream side, using a flexible grouting.
The cracks showed up early on, and by early 1928, Mulholland decided to chink those shrinkage cracks on the downstream face because he was losing water through them.
Chinking is a flexible sealant that's normally used on log cabins or wooden ships. But this was one of the largest dams in the world and made of concrete, so this was uncharted territory.
If you're gonna seal cracks, you have to seal them on the upstream side so that that water doesn't get internally into the dam.
But with the cracks sealed on the downstream side, water was getting in, and the pressure was building up inside the dam.
I think that was his greatest mistake he made in the project, because now you had the full reservoir hydraulic pressure build up internally, and that's not a good thing. You need drainage, not blockage. Had he not grouted the dam on the downstream face, the dam might have survived.
To make matters worse, the dam was built on unstable ground.
For me, I think one of the major issues for the dam was the geology of this area. It's really complex.
Some of the challenges, I think, were the bedrock material that the dam was founded on, and the abutments of the dam, which are the sides of the dam, what they're pressing up against. The arch effect relies on the pressure of those abutments to hold the dam in place, and so that may have been a big contributor.
As the pressure built, the thinner, weaker layers of rock gave way first.
There was a huge bedrock landslide that took the left side of the dam and carried it down across the dam and up the other side and send this huge turbid flood downstream.
Regardless of what ultimately triggered the failure, the investigation cited both engineering and geological errors.
When all these factors combined, the result was one of the biggest engineering catastrophes America had ever witnessed, on a dam that was less than 2 years old.
Following the disaster, William Mulholland took full responsibility. He never worked again, and new safety measures were quickly put in place.
The impact it had on the profession was huge, and that was because of the awful outcome. It had a huge impact on dams engineering worldwide.
St. Francis actually helped start the State Division of Safety of Dams, which was an agency that now regulates how we do our dams and maintains the safety of our dams. So that was the one shining light out of that.
What little remained of the original dam was dynamited. Today, nearly 100 years later, the site serves as a reminder of the hundreds of people who tragically lost their lives.
One of the greatest disasters in California history is finally being recognized here. It's just been declared a national monument. It's also been declared a national memorial. The second one in the whole state that's designated for the significant loss of life that happened.
Some fail strike while construction crews are still hard at work, but others can lie hidden for years before they trigger a catastrophe. Like this disaster in Italy, a catastrophic collapse of a vital crossing.
The entire concrete and steel bridge came crashing down in seconds.
Devastating destruction that rocked an entire community.
Cioè, l'ultima cosa che potevo pensare è che venisse giù improvvisamente e non ne rimanesse niente.
And an amazing escape for one very lucky driver.
In quel momento l'unico pensiero che mi è venuto in mente è che fosse finita, che fossi morto.
Tuscany is one of Italy's most popular tourist destinations and also one of the country's most rustic areas. Nowhere more so than the northern edge of the region, with hilltop communities forming near the River Magra, where people not only need to live off the water, but cross it too. Local journalist Emanuela Rossi knows this area well.
Siamo tra il mare e l'Appennino, le montagne, una terra di transito, è sempre stata una terra di transito. L'acqua è la vita, i fiumi sono stati chiaramente la via di trasporto per una terra che comunque è difficile, quindi sono fondamentali, sono sempre stati fondamentali, sia per l'agricoltura che per la comunicazione.
For centuries, the only way to cross the river was by boat. But in 1906, construction began on a pioneering new 260-metre-long bridge between the towns of Caprigliola and Albiano Magra.
This revolutionary bridge was one of the first in Italy to be constructed with reinforced concrete. Now used everywhere, at the time, this was cutting edge.
When it opened in October 1908, the 5-arch span of the Albiano Bridge was welcomed by people across the region.
Il ponte di Albiano era fondamentale perché unisce l'ultimo pezzetto della Toscana al di là del fiume Magra e non ci sono alternative, quantomeno non alternative adeguate.
But more than a century later, this crucial crossing would be in for a rough ride. On Wednesday morning, April the 8th, 2020, local delivery driver Andrea Angelotti was preparing for the busy day ahead.
La giornata è partita come una giornata qualsiasi, una calda giornata. Fortunatamente sono partito regolarmente dalla filiale, ho fatto un attimo una fermata breve insomma lungo la strada e poi mi sono diretto verso le prime consegne.
Around 10:25 a.m., Andrea was halfway over the Albiano Bridge when his day took a disastrous turn.
Mi sono visto il tratto di strada davanti a me che si è come impennato e poi mi sono sentito cadere, praticamente mancare proprio il sedile sotto di me. Mi è mancato e poi mi sono ritrovato. Inizialmente mi sono sentito proprio appunto cadere.
It wasn't just a feeling. Hundreds of meters of bridge suddenly collapsed, taking Andrea and his van with it.
Ma sarà durato, io penso, 2-3 secondi, anche se io lo dico di averla vissuta a rallentatore.
The catastrophic collapse caught everyone by surprise. First responders and Red Cross volunteers like Ivan Velardi were shocked by the devastation as they rushed to the scene.
Siamo arrivati qui e c'era un nuvolone di polvere incredibile, non si vedeva più niente. A che ci siamo guardati e abbiamo detto allora è successo davvero.
There had been no warning and no chance to escape.
E poi quando sono appunto arrivato giù ho realizzato quello che era realmente successo, che ero precipitato nel greto del fiume insieme a tutta la struttura del ponte.
Andrea was conscious but lying injured next to his van. Ivan raced down to the wreckage.
Arrivato nel letto del fiume, la prima cosa che ho notato è stato il furgone. Sono fiondato lì sul ponte, ho scavalcato, sono salito sul pezzo di ponte crollato e lì ho trovato Andrea lì disteso sull'asfalto.
Injured but still alive, Andrea was quickly airlifted to hospital.
In quel momento l'unico pensiero che mi è venuto in mente è che fosse finita, che fossi morto, perché quando mi sono sentito proprio mancare proprio il furgone sotto il corpo, poi invece fortunatamente una volta atterrato ho realizzato che sì, molto dolorante, però l'avevo scampata.
Another driver had also gone down with the bridge, but amazingly he too survived with only minor injuries.
This could have been so much worse. Luckily, this normally busy bridge was practically empty with only 2 vans on it at the time.
Beh, mi fa un effetto emozionante riguardare il ponte. Sicuramente adesso riguardandolo così ho la sensazione proprio che abbiamo sfiorato una grande tragedia. Proprio il lockdown ci ha permesso di non piangere vittime o avere una situazione molto più grave.
The 260-meter bridge had collapsed in seconds, with just 2 vans on it. Investigators needed to determine what had caused this devastating disaster. It appears the warning signs were already there.
According to reports, cracks in the deck near one of the abutments had been visible for years and was slowly getting worse.
The investigation is ongoing, but it's possible the cracks were a sign of movement happening within the bridge. In this type of crossing, the culprit could have been the very design features intended to prevent damage inside the structure itself. Giant hinges.
These aren't like hinges on a door, which lets it swing fully open and shut. These were there to allow small movements in the concrete structure, helping to prevent cracking as traffic passed over and the river pushed past the piers.
Professor of Structural Engineering Pietro Croce is on the investigation team.
We have 3 cylindrical hinges in order to allow the hinge to face the external forces. The rotation capacity is limited to very small angle because we are subject to movement which are very, very small. In bridges, this is enough. If all is okay.
But here it seems everything wasn't okay. Something was moving the hinges much more than they could cope with.
What was wrong was the collapse of the hinges, located near the abutments due to excess of rotation. When you require too much rotation, the hinge is prone to collapse.
What was causing the rotation? It's suspected that the ground on which the bridge stood for over a century wasn't very stable.
The construction of the bridge was interrupted when the riverbed was found to be weaker than first thought. This could mean that over time the soil around the foundations moved much more than first anticipated.
One of the possible cases is a movement of the abutment, and in that way you have the collapse of the first arch and then the second arch and the progressive collapse of the whole bridge.
With a bridge like this, the movement of just one support could explain why the whole thing came down. But even if the original foundations were strong enough, the river itself could have been eating away at them all along.
Fast-moving water can erode or scour away soil around a bridge pier, undermining its integrity. Now, this can be a serious problem where a river is prone to flooding, like this one.
The reason can be due to several causes. The final result is exactly the same. You have a collapse of the hinge and then collapse of the arch and, as a domino effect, collapse of the whole bridge.
With the bridge down, a crucial crossing that had stood for more than a century was gone.
Questo ponte unisce 2 regioni, 2 province, 2 comuni, cioè era un ponte essenziale, quindi in realtà ha messo in ginocchio i 2 piccoli paesini che stanno agli estremi del ponte.
While work has yet to begin on its replacement, the disaster may have highlighted an underlying issue with this country's aging infrastructure.
Another investigation found that Italy has around 1,000 viaducts and bridges which haven't been assessed in years. Any one of them could need maintenance to avoid a catastrophe like this from ever happening again.
For Andrea, while the road to recovery may be long and winding, hopefully he's on the right track.
Niente, si vede che io penso che potevo morire in quel momento lì, però sicuramente non era il mio momento. Io le sto passando di tutti i colori. Non per questo, insomma, ci arrendiamo, insomma, andiamo avanti. Ho la mia famiglia, fortunatamente, che mi aiuta, che mi sta molto vicino e vediamo, insomma, di superare anche questa.
When engineers innovate, every last detail is crucial. But sometimes pioneering structures bite back. Like this story in Massachusetts that had students running for cover.
People noticed that looks like some bricks were falling.
The world's tallest library was cracking at the seams.
I am just completely blown away by the sheer size and the magnitude.
This tower's fate was hanging in the balance.
Amherst, Massachusetts is a small town of 40,000. But for most of the year, the population nearly doubles thanks to its 3 colleges, including the University of Massachusetts. Aaron Rubenstein is the head of Special Collections and University Archives.
The university was founded in 1863. It was part of the Morrill Land Grant signed by Lincoln, and the idea was to build agricultural and technical colleges across the U.S.
A century later, the university was thriving and growing both in size and academic prominence. There was an ever-increasing need for a state-of-the-art library, but finding the space for it required some book smarts.
To have enough space for books and people, experts suggested the library would need a floor area of around 5 football fields. But in an already crowded campus, spreading out would be impossible. The only way to build would be up.
Completed in 1973, at a mammoth 28 stories tall, this towering library was the tallest in the world. Journalist Ron Charmless knows what makes this library so impressive.
As a structure, it's nearly the length, if you would put it on its side, of a football field, 286 feet, 28 stories, 5.9 million volumes. It's one of the sites that people want to see when they come to visit UMass Amherst.
In the 90s, the library tower was renamed in honor of a prominent Massachusetts scholar and civil rights activist.
W.E.B. Du Bois was born in Great Barrington, Massachusetts in, I believe, 1886. And he was ahead of his time as a racial pioneer. And I think naming this library after him, making it such an impressive structure, speaks to that.
Although the tower looks to be made of solid brick, it's just a facade. Max Page is a professor of architecture.
The Du Bois Library is in some ways a very simple building. It is a tower made out of structural steel with a facade, an exterior, attached on. In this case, it was a brick facade purely for beauty.
The facade is made of prefabricated panels about 9 meters high, with a layer of bricks already fixed in place. The panels are then hung on the outside of the building, kind of like picture frames.
The 28-story tower was constructed of steel and concrete, covered with hundreds of these brick-covered panels, each weighing almost 3 tons, supported from below by 12-centimeter deep L-shaped braces.
The facade really is attached and hangs on to the main structure, and that's where those very heavy-duty brackets played the role, because they were built into the main structure of the building and held up the facade, the 30 feet of bricks.
Every once in a while, when I come in the front door and I look up, I am just completely blown away by the sheer size and the magnitude.
But just 3 months after opening, this record-breaking library's hardback cover was beginning to crack.
this glorious opening of this tallest library in the world, and then people noticed that looks like some bricks or parts of bricks were falling. There was a little concern about it, but it wasn't really until several years later that finally someone said, we worry this is a real problem, like maybe the building will fall down. So that's when there was a huge investigation into it, and the library was then closed.
This was shocking. The library was only open for 5 years before people feared that it would fall down.
Engineers scoured the facade for clues to explain the crumbling.
When the investigation took place in 1979, and an initial engineering firm said that this could be really catastrophic, they moved the library books out, they said no one could go in, they put a fence around it, and they also put down bales of hay all around the library so that if the bricks fell, they wouldn't bounce and explode and hit people nearby.
No clear cause was found, and rumors began to circulate.
There are a lot of myths surrounding the Du Bois Library. One of them is that they didn't account for the weight of the books when they calculated its structural strength. It's not true. They absolutely did account for the weight of the books in the structure of the building.
One rumor had it that the library was sinking into soft ground because of a nearby pond, hence the cracking exterior. Again, this wasn't true, but clearly something was going on.
I think people were worried that those small brick pieces meant it was just the beginning, and that in fact the whole facade, which is all brick, all 28 stories, would come crashing down, or maybe the whole building was flawed.
Further investigation revealed that the problem wasn't with the whole wall. In fact, just a few bricks were cracking, known as spalling.
Spalling is a generic term for when bricks come under stress and buckle and ultimately kind of break apart.
And that spalling was only found where the brick panels rested on the braces.
It's at the intersection, at this brace, this intersection where there's lots and lots of compression. It's the bricks right around that kind of intersection point, around these braces, is where the spalling has happened.
This stress was factored into the original plans.
Part of the design was to allow the 6,000 pounds of brick that rested on this brace to have a little place to move as it expanded and contracted with the seasons. And so what they were supposed to do was have something called a soft joint, some kind of material that was just a little bit flexible so that as those bricks expanded, they would have somewhere to go.
But for reasons that remain unknown, instead of being flexible, the joints were hard.
There was nowhere to go when the expansion happened during the warm weather, and so that over time, it pushed out, and some of the bricks were kind of the release valve for the pressure of all this weight on this one spot.
This finally solved the mystery of why only bits of brick were being found. The whole wall wasn't failing, just the bricks around the braces, which were gradually being broken apart by the stress.
By 1983, engineers concluded that the worst of the spalling was over, and they declared the building safe once more.
Some repairs had been done, further investigations made it clear that the problem wasn't quite as bad as originally thought, and that the danger going forward was very minimal. So the state and the university was comfortable with the idea of allowing the public back into the library.
The only practical solution to repair the damage was to remove the broken bricks and patch up the cracks.
Repairs have been done on the facade to minimize the spalling, and so there's almost no reports of bricks or pieces of bricks falling from the facade of the Du Bois Library.
Just in case, a perimeter fence keeps people at a safe distance from the wall.
I actually have no fear about it. Once I learned a little about the history, I am happy to walk in there. There's no danger at all. And I'm actually glad that there is this heroic tower on campus.
Today, this is still the tallest academic library in the world and continues to be a beacon for the students and the university.